Okay, this section is complex numbers, and we're going to just start with a bit of background. Let's say we want to consider how to solve x squared minus 9 is equal to 0. Now what we're normally doing is just bear with me, we're normally saying moving the 9 to the other side, so you get x squared is equal to 9, change sign, x is equal to plus or minus the square root of 9, which is plus or minus 3. Now consider if we want to solve this one, okay, so we've got a plus in that position. So again, we're going to say x squared is equal to, moving the 9 across, you get minus 9. And then you say x is equal to plus or minus the square root of minus 9. Now, we haven't really come across the square root of a negative number before, and we need to kind of have some mechanism to deal with it. Now, what we do is we introduce the idea of imaginary number I, okay, and we say that I is equal to the square root of minus 1. Now what we say then, how we deal with it, is we say x then becomes plus or minus. Now we're going to split that minus 9 into the square root of minus 1 times the square root of 9. When I multiply minus 1 by 9, I get minus 9. Now the square root of 9 is 3, so we've got a plus or minus 3, and then we've got 3 times the square root of minus 1. And that would then be equal to plus or minus 3i, if I is the square root of minus 1. So imaginary numbers give us a mechanism to deal with the idea that we sometimes get a minus number under a square root sign. I'm defining I to be the square root of minus 1, so let's just look at I squared. I squared would be the square root of minus 1 times itself. Now when you square, if you square this, effectively the square and the square root sign cancel each other out and you end up with minus 1. So I squared is equal to minus 1 squared, which is minus 1. I cubed then would be equal to I times I squared. I times, now we've already said up here that I squared is minus 1, so we put that in there. Minus 1 times I is minus I. I to the 4 then is I squared times I squared. Now we already know that I squared is minus 1, so it's multiplied by minus 1 again for the other I squared. Minus and minus gives me a plus 1. So I to the 4 is a plus 1. And we'll deal with this a bit more later on. Let's look at the general forms then of complex numbers. We have what we call, so this is a typical complex number, 2 plus 3i. This bit, the 2, is called the real part, and the 3i is called the imaginary part. So our general form for complex number is a number plus another number times I. A is considered to be the real part, and B is considered to be the imaginary part. Okay, so how do you add complex numbers? Complex numbers behave very much like algebra, like when you're adding x's and y's, you added the x's together and the y's together separately. So you do the same for the real and the imaginary part. So let's look at this. You've got 4 plus 3i plus 3 minus 2i. Again, I'm going to just remove the brackets there. And then I'm going to group the real parts, 4 and 3 together, and add them. And I'm going to also group the imaginary parts. You get 3i minus 2i. Then 4 and 3 is 7. 3i minus 2i gives me an I. So your answer is 7 plus I. Again, for subtraction, remove your brackets first. Now I'm going to say minus 4 minus minus gives me a plus 5i. Then you just group the reals together. You get 3 minus 4, which is minus 1. And the imaginaries together is the 7i plus 5i, which gives you a 12i. And this is your answer. Multiplication, again, is similar to what we do with algebra. If we're multiplying two complex numbers, we have to split the first bracket and multiply it by the second. Plus 3i times 5 minus 4i. Again, we're going to do rainbows. 2 5s are 10. 2 times minus 4 is minus 8i. 3i times 5 is a plus 15i, and 3i times minus 4i is minus 12i squared. But don't forget, if I is equal to the square root of minus 1, then I squared is equal to the square root of minus 1 to be squared, and it's effectively then minus 1. So this bit here is a minus 1. So then you have 10 minus 8i plus 15i minus 12 times a minus 1. 10 minus 8i plus 15i minus gives you a plus 12. Now we simply group the reals together. You get a 22. And the imaginaries together, you get a plus 7i. Okay, so that's multiplication, very much like algebra. Just the last part of that exercise there was we want to simplify I to the power of something. Okay, so what you do is you split it. You use the fact that I to the power of 4 is equal to 1. And what you do all the time here is you're going to split that into powers of 4. You see you've got I to the 30. So what you say is that's I to the 4 times, now 4 into 30 goes 7 times, 4 7 is 28, that means I have 2 left over, 2 i's, so you're going to multiply it by I squared. Now I to the 4 is just 1, so 1 to the power of 7 times I squared. Now 1 to the power of 7 is just 1, so it disappears, and I squared is simply the square root of minus 1 to be squared, which is equal to minus 1. The next one here is something similar. We break it into powers of 4. I to the 16 is I to the 4 to the power of 4. 4 4s is 16. I to the 10 is I to the 4 to the power of 4 into 10 goes twice. That would give you 8, and you've got 2 left over to make 10, so you've got an I squared still. I to the 6 is I to the 4 times I squared. 4 and 2 gives me a 6. Minus I to the 12 is I to the 4 times 3. 4 3s are 12. That's that. That's a 1 to the power of 4 plus I to the 4 is a 1 squared. I squared. I to the 4 is a 1. I squared. I to the 4 is a 1, and that's cubed. And again, 1 to the 4 is just 1. 1 squared is just 1 I squared, and you still have another 1 I squared, minus 1 cubed is just 1, and you have 1 plus, now don't forget I squared just from up here is equal to minus 1, so this becomes minus 1. This is another minus 1, and you have another minus 1, so you have 1 minus 3, which is minus 2, and that's your answer. Okay, so go ahead and do every odd sum in that exercise 3.2. That should cover you. Okay, thank you.